Hello, boys. Uh, Welcome to all of you in my class. Especially this class is module 4, class 10 boys of English version, and this is physics class. I'd like to start my class with best wishes for you, that all of you are well and safe at your home. And we are very much happy. We are very much blessed that we are still safe, and that's why we will always be praying, and we will always be thankful to our Almighty. And at the same time, it will give me much pleasure if you support me, if you cooperate with me with your participation in class, because the participation is very poor, that is not matching with the expectation. But now you're at class 10, and you have just only admitted to class 10, promoted to class 10. So now there are lots of things to be known. There are lots of questions for you. So for knowing more, for making questions, you have to concentrate on class, you have to participate on class. So that participation will also encourage your teachers, and we will be very happy with your happy participation, with your just cordial participation. We were just discussing about current electricity, and in last class we had discussed about resistance. Finally, we just got the idea of resistance, and the fact on which the resistance varies. Resistance depends on which facts. We just had that idea that resistance depends on temperature, resistance depends on the length of a conductor, resistance depends on cross-sectional area of a conductor. And today we will try to have some more knowledge about resistance and another terms that is not directly resistance, that is called specific resistance, and the difference between resistance and specific resistance also. Can you recall the term resistance? What is resistance? We will try to differentiate between resistance and a new term that is called specific resistance. Resistance and specific resistance. What is called resistance? In a direct word, if we want to say directly, the blockage or the hindrance in the passing of electron through a conductor is called resistance. Due to movement of electron, the electricity just passes due to the movement of electron. So whenever the electrons get blocked or get any blockage, that is called resistance. So it depends on the type of conductor. For different kind of conductor, different kind of material, their resistance also varies over there. So we know about resistance. The unit of resistance is ohm, and we can calculate the resistance from this equation. R equals V divided by I, and the unit was ohm. Okay, but what is specific resistance? Specific means making something certain. So what is called specific resistance? If we want to define specific resistance, we have to maintain some condition over here. The first condition is fixed temperature. For measuring specific resistance, the temperature should be fixed. And second one is unit length of a conductor. Unit length of a conductor. Third one is unit cross-sectional area. This criteria was not mandatory for resistance, but these are mandatory in case of specific resistance. So if we want to specific resistance now, what is specific resistance? at fixed temperature. But just telling it, you can make a note from my words. At a fixed temperature, the resistance of a unit length and unit cross-sectional area is called its specific resistance. I just want to repeat it again. At fixed temperature, the resistance of a certain material, of a certain material or of a certain conductor with unit length and unit cross-sectional area is called its specific resistance. So we have mentioned here an important thing, that specific resistance is of the material of a conductor. But in case of resistance is just a hindrance of or blockage that is not involved with the material, but specific resistance is involved with the material of the conductor. Okay, and another criteria is it has to be maintained a fixed temperature there for measuring specific resistance, and it has to be unit length and unit cross-sectional area at the same time. But in case of resistance, there was no mandatory fact that for measuring resistance we have to mention unit length or unit cross-sectional area. তো বয়েস আমরা যেটা জানলাম, রেজিস্ট্যান্স হচ্ছে সিম্পলি একটা কন্ডাক্টরের মধ্য দিয়ে ইলেকট্রন প্রবাহের পথে বাধা। আর এটা কন্ডাক্টরের ম্যাটেরিয়ালগত কোনো ধর্ম নয়, কন্ডাক্টরের মধ্য দিয়ে ইলেকট্রন পাস হতে পারবে না, সেই বাধাটাই রেজিস্ট্যান্স। বাট স্পেসিফিক রেজিস্ট্যান্স বা যেটাকে বলা হয় স্পেসিফিক রেজিস্ট্যান্স, আপেক্ষিক রোধ, বাংলায় যেটাকে বলা হয় স্পেসিফিক রেজিস্ট্যান্স বা আপেক্ষিক রোধ, সেটা কি? সেটা হচ্ছে একটা স্থির তাপমাত্রায় বা অ্যাট ফিক্সড টেম্পারেচারে কোনো একটা কন্ডাক্টর তার ম্যাটেরিয়ালের ক্ষেত্রে, কোনো একটা কন্ডাক্টর যদি এমন হয় যে তার দৈর্ঘ্য বা লেংথ একক এবং তার ক্রস সেকশনাল এরিয়া বা প্রস্থচ্ছেদের ক্ষেত্রফল একক পরিমাণ, তাহলে সেই কন্ডাক্টরের উপাদান বা ম্যাটেরিয়ালের যে রেজিস্ট্যান্স তাকে বলা হচ্ছে স্পেসিফিক রেজিস্ট্যান্স অর আপেক্ষিক রোধ, যেটা রেজিস্ট্যান্সের বেলায় কন্ডাক্টরের উপাদানের রোধ বলা হয়নি, শুধু কন্ডাক্টরের রোধ বলা হয়েছে। ইন কেস অফ স্পেসিফিক রেজিস্ট্যান্স উই আর টেলিং দ্যাট দ্য রেজিস্ট্যান্স অফ দি material of that conductor. So I think you can differentiate the points over here between resistance and specific resistance. Specific resistance in case of determining the specific resistance. In last class we just have some equation for relation for which fact resistance depends on. I think you can recall those equation. R is proportional to L and R is proportional to 1 by A. Combining both those equation, we just got simply one. R is proportional to 1 by L by A. So here by omitting a proportionate sign we get R is equals, we can use a constant over here, L by A, and this constant rho, this is the symbol and this symbol is called rho. This is called specific resistance. আমরা রোধের যে সূত্রগুলো পড়েছিলাম সেই সূত্রের মধ্যে সেই সূত্রকে কম্বাইন করে পেয়েছিলাম আর সমান রো ইন্টু এল বাই আর ইজ প্রপোর্শন টু এল বাই এ। প্রপোর্শন সাইন আমরা তুলে দিয়ে এখানে একটা কনস্ট্যান্ট লিখছি যেটাকে রো বলা হয়, এবং এই রোটাই ডিনোট করে স্পেসিফিক রেজিস্ট্যান্স বা আপেক্ষিক রোধকে। দেন ফর স্পেসিফিক রেজিস্ট্যান্স উই ক্যান রাইট দ্য ইকুয়েশন অ্যাজ আর into A divided by L. From here we are just determining this one. Rho is equals R into A by L. So we know the unit of resistance, unit of cross-sectional area, unit of length. Using all those unit we will get the unit for specific resistance. Rho equals ohm meter. The unit of resistance is ohm. The unit of cross-sectional area is meter square, unit of length is meter, so dividing it we just get the unit of specific resistance is ohm meter. So we have got some clear conception between the difference of resistance and specific resistance. What are those difference? First of all, we can differentiate them according to their definition. What is called resistance, what is called specific resistance. Then we can make difference by their equation. This is the equation for resistance and this one is for specific resistance. Then we can make a point that specific resistance needs the confirmation of a fixed temperature, unit in length, unit cross-sectional area, but resistance doesn't require this confirmation. And finally, the resistance is the property of a material of a conductor, but specific resistance is the property of the material of a conductor. So these are the some points about the difference of resistance and specific resistance. There is another term that is called conductance or conductivity. The opposite term of specific resistance is called conductivity. Specific resistance is resistivity, and the opposite term of specific resistance is called conductivity. This is denoted by sigma. This is called sigma, and this sigma denotes conductivity. Conductivity is equals 1 by rho. That means the reciprocal term of specific resistance is called conductivity. Okay, so its unit will be the reciprocal of the unit of specific resistance. The unit of conductivity will be ohm meter per ohm meter. Okay, so don't confuse with the unit. If you just have a clear conception about the terms, then it will be easier for you to recall the units over here, recall the definition of over here. Here we have known resistance, then specific resistance, then conductivity, and everything is related to one another. Okay. Then an important term, the relation between resistance and temperature. Whenever the temperature rises, this symbol is symbolizing that temperature is increasing. If temperature rises in case of conductor, the resistance also increases. As the temperature rises or increases, the resistance of a conductor increases. But in case of semiconductor, if the temperature rises, then in case of semiconductor, if we want to say about semiconductor, then for semiconductor, if the temperature rises, the resistance decreases. This is symbolizing that resistance is decreasing. What is the explanation over here for this point? Whenever temperature, if we know about the property of a conductor, if we assume it as a conductor, we know that conductor consists of so many free electrons. If we consider this as electrons, and the conductor, this is a material consisting of so many atoms. These are just assuming like atoms. These blue shaded dots are just representing as atoms, and the tiny dots are just we are assuming as electrons. These are electrons, and these are atoms of that conductor. So if the temperature rises, then what will happen here? The electrons are free over here, so they will get extra or the atoms of the conductor, they will get extra energy. We were applying heat, means we are providing here extra energy, so atoms and the electrons will have more movement than earlier, as they are getting extra energy. So due to their movement, the free electrons and atoms of that conductor will have collision, more collision. At the more temperature, the collision will be more over here. Collision means electron will collide with these atoms, and that means they will have a blockage, they will have a hindrance in moving. So this hindrance is called resistance. যখন একটা কন্ডাক্টরের মধ্য দিয়ে ইলেকট্রন কন্ডাক্টর মানে সেখানে অলরেডি কিছু ফ্রি ইলেকট্রন রয়েছে, পর্যাপ্ত পরিমাণে ফ্রি ইলেকট্রন রয়েছে, যাদের কারণে এই কন্ডাক্টরটি কন্ডাক্টিভিটি শো করছে। এবং যখন টেম্পারেচার সাপ্লাই করা হলো এখানে, তার মানে টেম্পারেচার দেওয়া মানে সেখানে এক্সট্রা এনার্জি প্রোভাইড করা। সেই এক্সট্রা এনার্জির কারণে এই ইলেকট্রনগুলো, কন্ডাক্টরের যে অ্যাটমসগুলো রয়েছে, অনেক বেশি ছোটাছুটি বেড়ে যাবে, মুভমেন্ট বেড়ে যাবে এবং তাদের মধ্যে কলিশন বেড়ে যাবে। কলিশন বেড়ে যাওয়া মানেই ইলেকট্রনের মুভমেন্টের পথে সেটা বাধা তৈরি হওয়া। So that's why whenever the temperature rises, the resistance of a conductor also rises. But if we want to say about semiconductor, in terms of semiconductor, this was a conductor, but if I just assume a semiconductor, we know the property of semiconductor. At normal temperature, semiconductor has very few electrons that at আমরা জানি যে at normal temperature semiconductor মধ্য দিয়ে ইলেকট্রন ফ্লো হয় না, অর্থাৎ কন্ডাক্টিভিটি শো করে না। অ্যাটমসগুলো থাকে বাট খুবই নগণ্য পরিমাণে ইলেকট্রন থাকে, যার কারণে সেমিকন্ডাক্টরের মধ্য দিয়ে কোনো ইলেকট্রন ফ্লো হয় না, অর্থাৎ ইলেকট্রিসিটি পাস হয় না। বাট these are electrons. Whenever we are applying heat over here, heat apply করার কারণে কি হবে, huge amount of free electrons will generate over here. Though at normal temperature there was a very few free electron, but as the electrons are getting extra energy, huge amount of free electrons will generate over here, and as the electrons are generating, so there is the probability is creating for more current. যেহেতু এখানে জেনারেল নর্মাল টেম্পারেচারে নগণ্য পরিমাণে ইলেকট্রন ছিল, বাট হিট অ্যাপ্লাই করার কারণে, টেম্পারেচার প্রোভাইড করার কারণে অনেকগুলো ফ্রি ইলেকট্রন এখানে জেনারেট হবে, এবং ফ্রি ইলেকট্রন তৈরি হওয়া মানেই তো সেখানে ইলেকট্রিসিটি ফ্লো হওয়া, আর ইলেকট্রিসিটি ফ্লো হওয়া মানে রেজিস্ট্যান্স কম হওয়া। রেজিস্ট্যান্স হলো ইলেকট্রিসিটি ফ্লো হওয়ার পথে বাধা। More electricity means less resistance. So that's why we can conclude that whenever the temperature rises, in case of semiconductor, the resistance decreases. Most of the time these questions come to your exam for knowledge based question, comprehensive type question. So I think the concept is clear to you. If you just have a look on your book, then everything will be clear to you. Next, we will try to know about fixed resistance and specific variable resistance. In case of fixed resistance, there are two picture to your book. If you just have a look on this picture, these are the examples of fixed resistance. That means all these resistors have fixed values, but the right one here, this is a variable resistor, because for some function of the circuit we need resistance that will be varied from time to time. That means for some function we need a resistance, for another function we need another resistor. So we can just replace the circuit element from the total circuit. So if we apply a variable resistor there, then using a simple resistor we can get variable resistance according to our need. Here is a knob, black knob. By moving black knob back and forth, we can get variable resistor over here. এগুলো হচ্ছে ফিক্সড রেজিস্টর, যেগুলোর এক একটা ফিক্সড ভ্যালু আছে, ওহমস আছে, কিলো ওহমস আছে, মেগা ওহমস আছে। ওহম যেহেতু ডিরেক্টলি ইউনিট অফ রেজিস্ট্যান্স, সেই হিসেবে বড় এককগুলো কিলো ওহম, মেগা ওহম হতে পারে। আর এটা হচ্ছে ফিক্সড ভ্যারিয়েবল রেজিস্টর। ভ্যারিয়েবল মানে এটা ভ্যারি করে রেজিস্ট্যান্সটা। ব্ল্যাক নবটাকে সামনে পিছে নিয়ে মুভ করিয়ে এখানে ভ্যারিয়েবল রেজিস্টর পাওয়া যায়। আর ফিক্সড রেজিস্টরের দুইটা এন্ড থাকে, দেখতে পাচ্ছ দুইটি এন্ড আছে, বাট ভ্যারিয়েবল রেজিস্টরের তিনটা এন্ড থাকে। থার্ড এন্ডটা ব্যবহার করে রেজিস্ট্যান্সটাকে ভ্যারি করা হয়। So we have known the difference of fixed resistor and variable resistor. Variable resistor is there is another name of variable resistor in practical use. That one is mostly used, that is called rheostat. Or this is the short form of variable resistor. In practical use, rheostat is used as variable resistor. This name rheostat is used mainly. So we have known about resistance, specific resistance, the effect of temperature on conductor and on semiconductor, and we have known about fixed resistance and variable resistance. On our next class, we have some more discussion about circuit. We will just have basic knowledge. We'll try to have some basic knowledge about circuit, and we will try to solve some circuit also. So that's all for now for today's class. I want to disclose the class now, and I want to break my class with praying for you that all of you guys have wonderful time, and praying for your healthy and happy life. Thank you to all.